Alright, I just sent you a file through checkbox as well as your WhatsApp. We check if you see it, and we will continue on the other two concepts, which is metals as well as exit base. Right, a very authentic topics we have got to frequently asked questions there. Have you all received it? Right, you should have that file. You got it? You got the file? Oh, I was just referring to this on this. Okay, have you all received this one? Okay, we start from metal today. I'll spend some time on it, and while you are doing some preparation on that, I would like to check the attendance. Let me see. Okay, spend some time on doing that one first of all. And we will go over with you later. Okay, just wait for me. I need to mark the attendance. Now, once again, I say once again, did you all receive the file?
Yes.
Thank you. How about the others? Hồ Diễm Hằng, you all received the file? Oh, Hồ Diễm Hằng not here. Just enter. Yep. Thank you. Start from metal. And just check against your name first of all. Something. John Ho for Trần Hô Hey. Where are you, Zhang Gaowing? Hồ Diễm Thọ. Hồ Diễm Thọ. Hồng Cao彩. Mặc dù là Quân Ngọc Di. Siêu Trần Hey. Hoàng Trân Hey. Yeah. Trang Hàn Ngoại. Trần Chi Hiên. Okay. All right. Okay, shall we have a start on this? Yeah, metals. Chẳng kiến hay. The first one, the year of discovery solely depends on the use of extraction of metal.
solely 係咪淨係啊？
Yeah.
咁應該唔係 solely 應該仲有其他 factor。
So what is that?
誒
Don't use your so-called exam skills to judge. You should give.
佢嘅蘊藏量咯，喺地球嘅蘊藏。
Okay, availability or the abundance of metal. Yep. So you know that we have got two important routes, and ease of extraction is mainly dependent by what?
Reactivity.
Reactivity of metals. While how does it relate reactivity of metals and ease of extraction?
越 reactive 嘅話就越難去 extract 出嚟。
Why?
因為佢係好 stable 喺佢嗰個 oxide form。
Yeah, we need to add one more term: stability of the metal oxide. So we have got two routes, right? Two factors that affect the year of discovery of metals. Okay, so this one, the other one is availability. Okay, the more abundant the metals, the earlier the metal will have a chance to be discovered. But of course, it is we need both factors to consider. Huh? So you may experience some time where it's quite abundant, but it is quite late to be discovered. For example, aluminium. Aluminium is the most abundant metal, okay, on the Earth crust. But I found it is 1H07, as I remember. Okay, AD. A very long time ago, 1H27 AD. A very long time. Okay, and it needs some high technology electrolysis of molten ore to extract. So this is what to make a start for metals. Okay, now second. Next guy. 蔡用上。蔡用上。Are you here? Yeah? Tell me your thoughts. The magnesium reacts with water to form magnesium hydroxide and hydrogen gas. Not soluble. So you may focus on the later stage, okay? But at the very beginning, would they form magnesium hydroxide? And you said that react with steam, but the question asks for reacts with water. I wrote this statement. So you have to tell me whether or not, for Yulam's case, you have to tell me whether or not magnesium reacts with water before you tell react with steam, okay? Many metals react with steam. First of all, does magnesium react with steam, with water? forgotten. Cold and then cross, cold water cannot. Okay, so what is the hidden message? The water here is somewhat too general. If you want to make it react, right, cold water is not. So how will you change it? You want to tell me magnesium doesn't react with cold water? Or if you want to make it react with, besides added word steam, what else can you add? Hot water, is it okay? Can you get the point? So there are many ways to present the idea about this. So first of all, if you want to change this, first of all, try to see if water would really react with magnesium. But of course, the more that you discover inside, you may find the word cold or hot is somewhat a key terms. Okay, according to the reactivity series of metal, KNaCa, that 3 they can react with water, and then Mg is hot water. While and then we'll have got other one, aluminum, zinc, iron, etc. While from actually, you will see from the book that you may see that we react with steam. How about that 3? Can it react with steam also? How about the first 3? Can it also react with? Forget. It's not matter of word forget. You forget the whole concept. You will say that steam, you don't know whether or not it reacts with the first 3 metal, which means the whole concept you forgot. But not forget the factual information. 唐家豪, what do you think? Potassium, sodium, calcium. Is it possible for that 3 metals to react with steam? I don't know whether or not what's the mean by word yes. Somebody love to, right? Especially your teacher love to answer me like yes and then question mark. It gives me some confusion. I don't know whether or not they want to draw my attention again. Yes, and then what I can do is to ask them to open the camera from the very first lesson. Good. Yeah, it's explosive. So of course it would react with steam, but it's more reactive to steam. Okay, so what will happen is that it's somewhat explosive. Okay. Can you get the point? And how about that first sentence? I just copy from one student work. Wang Junhou. When a piece of calcium is put in a copper sulfate, calcium reacts with sulfate to form insoluble calcium sulfate, which prevents the further reaction. Wang Junhou, where are you? Calcium sulfate will coat on the calcium. Okay. Trần Nghĩa, you just mentioned sulfate ion question mark. What do you mean? Last sentence is quite weird. I've been seeing those sentences for 3 years. Okay, in your batch of students, right? I've seen that for 3 years. I don't think it's weird. So common. So what's the point? Anyone can tell? Or you think that the calcium sulfate will coat like calcium, and then? So what is the whole thing? What do they want to tell actually? Instead of mentioning, yeah, they tend to mention something about coating effect. Yeah, so if you're the one to change, how to change it? How to change the whole thing? Have side reaction. Tan Hei mentioned is there is a side reaction. Yes, that is true. But that is sidetracked from this main sentence. Is stray away a bit from this intention to write such. They want to tell, first of all, displacement reaction. Okay, and then they want to elaborate something more about coating effect. So how will you change the whole thing? 肖俊熙
早晨，先生。
Yeah, just tell me about this sentence, how to modify the whole sentence. The calcium would combine with sulfate iron. The calcium, which means what? The calcium metal or the calcium ion or what? Marcus, take a look on your words.
Calcium reacts with water.
Calcium reacts with water. Okay, you and Chan Ho-hei are good friends. Okay, you two share the same. What else? So indeed, can you manage to write down the ionic equation for this? Now, you know, it's displacement reaction. Calcium is not 2+. Everything starts from calcium metal. Okay? And then metal together with copper 2 sulfate. But this time I would mark sulfate here. Why? Because later on we would have that insoluble substance, calcium sulfate, and together with copper here. So which will, and this is the coating, right, that cover the surface of the calcium, and they will prevent so-called further reaction. Why is it say the further reaction? Indeed, originally there is a reaction. Okay, that coating will not be formed so instantly. Okay, so that coating will be formed in a thicker and thicker sense. Okay, when time proceeds. Can you get a point? So when time proceeds, first of all, calcium will react with sulfate to form calcium sulfate. A couple of sulfate to form calcium sulfate, but that layer, right, will start to form, which cover the surface. But it's not just calcium sulfate, okay, but also copper. Copper will also play a role, but of course, that two chemical will start to coat on the surface, okay. And finally, when the coating is of the certain thickness, what will happen? A complete isolation of the metal and the metal underneath, and the copper sulfate will occur. So which hinders the displacement reaction. So the reaction will stop. So first of all, calcium react with sulfate to form calcium insoluble calcium sulfate. So that sentence is problematic. Now, because if you stick back to the displacement reaction, it seems that the calcium loses electrons and the copper to iron, they will gain electrons to form that reaction. And indeed, once they form this pattern, they rapidly form calcium ion, which will combine with sulfate ion to form calcium sulfate. Okay, can you get a point? So that is not, we have got free calcium ion react with sulfate, right? That type of change is very instant. And second, if you want to talk about further reaction, go back to the original reaction. There is some reaction, but no reaction. Okay, there's little reaction. As long as the calcium would have a contact with the solution, copper sulfate, the reaction still proceeds. Okay, until the coating is thick enough to prevent the contact of calcium metal underneath to react with copper sulfate. Can you get a point? So this is what you know something about coating effect. Of course, what Chen Haohei and Xiu Junhei suggested is also true. Okay, but in these questions, while they are talking about coating effect, first of all, taking a look on the sentence, is it truly reflect the or the wordings, they are correctly describing the whole thing. So we focus on this one first of all. And later on, you think of other reaction. Can you get a point? So this is the way to correct the whole thing. Now, what will happen to the product? Is it just calcium sulfate, copper diazole? Of course, there may be more. Now, for example, calcium hydroxide. Now, you say that calcium would react with the water inside the, which is a solvent of copper sulfate solution. They will also form calcium hydroxide. While with the certain, with the limited solubility of calcium hydroxide, they maybe also have a chance of forming calcium hydroxide as well. Okay, but of course, it's just side dish for this case. If you want to mention days of the displacement reaction, there is a coating effect. Can you get the point? Okay. So this is that questions, right? That is the core concept about this I want to convey. So remember, it's the way to present the ideas, and I would like to check the word by word. And Chen Haohei, definition of displacement reaction. A more reactive metal displaces a solution made up of less reactive metal. What is displaced? The solution is displaced, you mean? This is something about English. A more reactive metal displays. It seems like they're made up of something. It's just a further description to describe the solution, right? So if that means the sentence from this to this can be omitted, and you take a look on the simplest meaning, which means a more reactive metal displaces a solution. Do you mean that? No, but you write it like this. It's something about English.張家榮 displacement reaction, the definition of it. Displacement reaction. Hi, Zhang Gaowei, where are you? You just fell asleep again. Where are you? Yeah, the more reactive metal displaces the less reactive metal from its compound. Or in the solution, right? If you want to tell the displacement reaction being held as a solution like. Okay. So you may see this term also in halogens. How about halogen and halide? For the reaction between chlorine and bromide, for example, it is also a displacement. Is it also a displacement reaction?劉文靜喺度。
係 displacement 應該因為 chlorine 變 chlorine， 跟住 bromide iron 變 bromine 咯。
Is it according to the definition? Is it also displacement reaction? Is it also called displacement reaction?
Not because chlorine and bromine is not a metal.
Mm-hmm.
Displacement refers to the metal form on the less reactive metal form on the more reactive metal on the waste. Should be element. I think it's correct because chlorine is reduced, is oxidized to form chloride iron and brom。好多講翻中文。跟住 Br minus 佢會變做 Br2 咯，所以應該係。
So displacement reaction, we will see this term twice. The first one is metal. While you would talk about displacement of a metal, okay, of a metal, we will say that the more reactive metal displaces a less reactive metal from its compound of the solution. Okay. So, Funong, you want to say something? Yeah. Also, you want to get response to Chen Qinghei? But it's not just direct coupling, but you have to tell the way to see that question is on the other one. For non-metal, it is exemplified by halogens. Okay, for halogens, we could also see the word displacement reaction. So which is said to be what is said as more reactive in this sense. Okay, so we will focus this as redox. So both can be explained in terms of redox. In terms of one of them, oxidizing power for halogens, but for metal, we focus on reducing power. Okay, so to relate those. Okay, so if you say that displacement reaction for metal, you just treat it like the one on top. For example, magnesium plus copper 2 ion to form magnesium ion plus copper. And also you can think of halogen if you want to talk about displacement reaction for halogens. It's chlorine, we have bromide to form chloride and bromine. Okay, so the way to compare is a little bit different. Now, once again, just check with Zhang Gaowing is here. Zhang Gaowing. Nope, not here. We'll move it into the waiting room. Just let them wait outside. And Marcus, do you still remember that? Rusting, corrosion. What are they in common and what is the difference?
Rusting and corrosion both involve oxidation, but corrosion is a more general and broader term that would apply to all metals, while rusting is specific to iron.
So what type of oxidation it is? So rusting or corrosion? What type of oxidation? A type of deterioration. Okay, you will say that a rather slow reaction. But of course, if you want to talk about the metal directly react with oxygen and water, that reaction can be fast. Okay, but the focus is on the uses of metal. They are no longer be so useful because of the deterioration of a property of the metal in response to its reaction. Okay, you think of the reaction between maybe oxygen, water, and other substances. Okay, so we will focus on rusting simply because rusting is it refers to the corrosion of iron. Okay, while the corrosion can refer to any metals that undergo deterioration upon the reaction with oxygen, water, etc. Okay, so this is what you may know about this part. So for iron, here comes this, the chemical nature of rust. So remember, rock corrosion is somewhat big circle, while the rusting is a smaller circle. Okay, Macula, chemical nature of rust. Not Yola. Fe3O4XH2O. Is it? No, not really. So what is the color of Fe3O4? Do you know the color of Fe3O4? And how would you form Fe3O4? Not really. Fe3O4, first of all, no hydrated form. Second, it's in black. While you mention it's reddish brown. So what is that? I just mentioned it here. Hydrated iron 3 oxide. This is the one. So this is the chemical nature of rust. Okay. This is the chemical nature of rust. While the equation. Now Fe3O4, first of all, how will you produce it? You can produce it in terms of, for example, burning iron in air. Okay, they will form Fe3O4. But for the rusting, they would mainly form iron 3 oxide, which is in hydrated form. Okay, do you understand? But do not get confused. The one with the reactivity of metal, the one I know where you have such an idea. The heating a piece of iron for long time in the heat air, they will produce Fe3O4 instead. How about the equation? You must know how to draw the equation well. What are the equations involved? Yeah. Okay. Correct. So this is the equation, and it seems that Chen Wuhei's handwriting is much better on the screen rather than on the paper. So you better send a letter of complaint to the HKEAA complaining why not you can draw it onto using this Apple Pencil. Now, so this is the one. Mayulam, you know the equation? Response please, Mayulam. You know the equation? Now, Wang Zhenhei. Now, this one you have to memorize, Mayulam. This one, you have to memorize this instead of just keep reading with air. A very commonly seen questions. Wang Zhenhei, the role of hexacynyl free ions and phenolphthalein in plus indicator.
phenolphthalein 咧係去 test 嗰個嘅hydroxide ion around 嗰個嘅 rusted iron 啊嘛係咪？而嗰個 hexacynyl free ions 咧係去 test 嗰個 presence of 嗰個 Fe2 plus 同埋 Fe3 plus 嗰個 iron 啊嘛。
And Fe3 plus.
Yes.
Mean like this? Agree? How about the others? Agree? Now, indeed, hexacynyl 3 ions is somewhat very strange chemicals. It may form a complex with iron 2 only. Okay, it may form a complex iron 2 only to form a Prussian blue complex. While for alkaline, for hydroxide ion, it changes the form of phenolphthalein to somewhat pink. So the principle is like this. So for iron 3 ions, you may use hexacynyl 2 ions instead of 3, okay, to have the detection of those. And of course, you may think of some other chemicals to test for the presence of iron 3. For example, anyone who can give me an example? Any means to detect for the presence of iron 3. Thiocyanate ion with you omit the negative charge, SCN minus ion. So what is the color? What's the observation? When it meets iron 3? Blood, no, it's not blood, it's blood, it's blood red complex. They will not turn to blood. Two different concepts. If they turn to blood, it seems like alchemists, right? Turning any metal to gold. Okay, so it's thiocyanate. All of you, please mark it down. Thiocyanate ion react with iron 3, they will form thiocyanatal iron 3 ion, which is in form of a blood red complex. So blood red here refer to the description of the color of that red. Okay. Now, I pass the time to 潘樂之 chemical principle of rusting.
Principle.
What is the chemical principle of rusting?
The iron metal is oxidized to form. It's oxidized by the oxygen in the air to form iron 2, iron, and then iron 3. After that, it reacts with water to form the hydrated form of iron oxide, which is rust.
Yeah. So according to the book, we will see that for first step here comes a red dots, right? Everything is a chemical principle rusting. It's what we call it as an electrochemical cell. So this is what you start from this, okay? And we have got two equations which marks the start of the rusting. Now, rusting is a rather complex multi-stage reaction. So I just want to go to you the first step. The first step will involve that, okay, to form one part which is for iron 2, the other one is for hydroxide. Okay, for hydroxide. And because of this, it's water, I'm not bro. Because now, because of this, it marks the start of the reaction, and it seems like what the first one is what they call the anode, the other one is a cathode. So for the piece of iron, which is surrounded with some moisture here, so it seems like an electrolyte. While the reaction will proceed like this way, we have got anode, we've got cathode, we have got a electron flow like this. Okay, so you may find, first of all, find some area in which there is a rusting, sign of rusting, first of all. For example, for a piece of iron nail, you will see of two versions on the book. One is the blue at the center, while the pink at the end, at both ends. The other one is the other way around. Which one is correct? You may have seen that two versions before in the book.記唔記得？有問有印象？陳龍喎。所謂藍色、粉紅色喺邊度揾到啊？好似唔記得晒啦，大家。好，有問答到，得個藍色有粉紅色㗎嘛？咁我喺本書入邊咧出現過兩個 version 嘅，其實 head and tip is blue color。鄭權威 suggested we say that head and tip is blue color is blue, while in the middle is pink, right? You mean like that? Why? 鄭權威 why? Why？ 有問答到點解？哇！去到 metal 棘棘地喎，講咗成個鐘喎。 咁我仲有3個未講喎，我原本諗住想講埋 exit base 嘅喎，哇！反而呢度搞得耐喎你哋。More easily to be corroded. Why? You just give me a fact. But I need the reason. More easily to be corroded. Why?冇人答到。即係知其然嘅喎，但係唔知點解嘅喎。問多次啊，龐家豪。咁點解 rusting occurs faster in sharp region？ Pack less closely. Why? Why do we have a sharp region packed less closely? I just make it sharp only. How does it relate to the packing? Now, of course, if you say such on some band region or the way the position where there is a welding area, just like the head of the nail, right? We've got 2 pieces. Now, actually, for the making of nail, we have got 2 pieces. The one which is the stick and as well as the plate here. So we have got that welding of the 2. While the welding area here will start to rust, while the pointed region will start to rust. It is something related to what? Surface area, yeah. For Chen his work is better. It's somewhat about surface area. If you want to talk about bench region, it is somewhat place where there is a fatigue of the metal. Okay, while you would also relate to the surface area of that. Okay, you understand? So that's why for the direction of electrons, flow will be from the both ends back to the middle. So in the middle it is pink, while the surrounding region around the 2 heads and tails here it is found as blue. Okay, just ask you some more basics here. Now, 嚟揾證 galvanized iron provides sacrificial protection to iron.
No, not sacrificial protection.
So what is that?
It just acts as a protective coating.
Protective coating. So what is mean by
Protective coating, also the sacrificial protection.
Well, it depends on whether the layer of
the
is
surface or not.
scratched. Yeah.
If there is a scratch on the galvanized iron, and iron is exposed to air, but zinc will loses electrons more readily as it still have contact with iron metal, so it loses electrons rather than iron to loses electrons from rusting.
How about a piece of galvanized iron? Do you mean that there is a piece of iron fully coated by a layer of zinc? So the key point should be here, right? So for the galvanized iron, if you are having a galvanized iron having the layer of zinc totally covering the whole piece of iron like this, okay, of course zinc in this case, even though it's set as a higher reactivity metal when you compare with iron, they will not say anything about sacrificial protection. Okay, it's because of the fact that the iron itself, if you want to consider it undergoing rusting or not, iron, of course, we will not undergo rusting. Okay, it's simply because that iron will not have a direct contact with oxygen and water outside. So it is a complete isolation, okay, between the iron underneath and the surrounding environment. Okay, so it is not sacrificial protection. Can you get my point? It's not sacrificial protection if that is the case. So we will say zinc provides what we call it as a protective coating. So which will prevent the direct contact of oxygen and water, direct attack on the piece of metal. Okay, so it's not just zinc can be a coating. Also, you may think of grease, some oil, other metal, even though lower reactivity than iron, for example, tin, plastic coating, etc. So all those belong to the same principle. Okay, but if you say sacrificial protection on it, you are going to think of the scenario. We have got piece of iron, we've got piece of zinc, both. If I place it in the air, we will have got oxygen and water. They were directly in contact with the two metal. So which means the two metal will undergo corrosion, okay, at their own pace. But the being how those two pieces of metal in contact will make the iron rust less readily. Now it's because zinc provides a platform to provide some electrons to that, because zinc loses electrons more readily. So can you get a point? So you should go back to the condition, first of all, to the essential fact conditions for rusting to occur before you tell it is or not a sacrificial protection. Okay, so sacrificial protection should be based on the fact that the piece of iron will undergo rusting anyway, and the essential factors are there, and use this to compare. Okay, you know the reference point. The reference point should be the iron piece of iron undergo rusting normally. Can you get my point? The basis of comparison is different. Second, metal plating, metal coating, electro plating. That three terms. What are the differences between these three terms, or any similarity of the terms? Xiu Junheng again. Metal plating, metal coating, electro plating. Are they talking about the same concept?
Metal plating 係要呢一個metal plating 同 metal coating 都係即係 form 一個 layer of form 一個 layer 喺一個 metal 上面，但係 metal plating 就一定要係嗰個我唔記得個 process 叫咩名，但係要係
process 咯，
要係用metal coating 就係可以 coat 啲唔係 metal 嘅嘢喺面，叫 metal 咦唔係喎，但係 metal coating 我唔肯定啊，不過但係我覺得就咁英文咁樣睇 metal coating 係可以係淨係即係 plate 一陣 metal 喺面，然後 coat 一陣 metal 喺面 ，metal plating 就係 I don't know whatever shit， 跟住 electroplating 就一定要用要用電去做呢一個 plating， 但係我唔知喎。
喂，咪就係問你哋咯，因為你成呢啲字成日出現噶嘛，係。
我不如簡單啲咁講啦。咁其實咧，佢嗰三個方面咧，即係三個方法咧，都係有陣layer 咧係擺咗上去嗰塊 physically 擺咗上去 metal 嗰個嘅表面上邊。咁而佢第三個都係去防止嗰啲嘅 oxygen 同埋 water 咧都去 react with 嗰個嘅 metal surface 啦。咁跟住就係至於個方法咧，即係你話如果 plating 同埋 coating 嘅話，咁我就係將一紮嘅 layer 就咁即係 physically 咁樣 整上去，但係 electroplating 佢係透過一個 electrochemical series electric 係透過一個 electrical 嗰個 ECS 去即係咧等嗰啲 metal 咧可以即係就咁即係想 plating 嗰隻 metal 咧 plate 到上去咯。
其實黃俊熙都解到一大部分啦，其實都好犀利，因為咧嗱 metal coating 咧同 Ben 少講咧亦都有啲類似嘅，就係嗱你話 coating 又好 plating 都好，其實都係有一浸嘅物質，咁就包住嗰浸 metal 嘅。We have got a layer of something, okay, that will cover on a piece of metal. But for metal plating, okay, for the metal plating, which means that I plate it with apply a layer of the metal. While the method can be a little bit different. There are two ways. To make that or the layer of metal onto a piece of metal. The first one is electroplating. The second term I would like to share with you is on hot dipping. Have you ever heard of this term? Hot dipping. Now, hot dipping. Okay, both would require applying a layer of metal, okay, on a piece of another metal. Okay, hot dipping or electroplating. Okay, so metal coating is somewhat a very general term. So it can be coated by not only metal but also non-metal, or maybe plastic coating, for example. But if you want to say that metal coating, which means coated with a layer of metal, so if you say these two as a metal plating and a metal coating, which means that apply a layer of metal onto something. Can you get my point? If you say that metal coating itself, it can be coated with so many things. But you will say that a metal coating, very often we are now referring to the piece of metal coated with something, which is a metal. Okay, the purpose of having this is to enhance the corrosion resistance of the metal. So metal coating is somewhat very general. Okay, but if you want to take a look on the method of the two, they are mainly undergoing by two. One of those. One is electroplating. The other one is hot dipping. For electroplating, it deals with the metal having a very low position in ECS. Okay, for example, silver, copper, etc. But for hot dipping, the layer of a metal will be coated on it, just like zinc, for example, galvanization. Right, galvanization usually use a hot dipping method to apply a layer of a metal, okay, on a piece of iron. Okay, and finally we have got that two terms. They are totally irrelevant. But why do I need to put it at the same place? Is the word cathode and anode. Okay, anyone who can tell? Cathodic protection and anodization 有冇話到我聽有咩分別？最後一個啦。Marcus。
Hey, what's up? My family is going to wake up, so I gotta type it.
Now, first of all, the materials to be dealt with is different. Cathodic protection and anodization is different. And the principle is different. So what are they? Now, cathodic protection refers to what? To a protection corrosion protection method for iron. While for aluminium, for anodization is mainly for aluminium. Okay, for iron, it cannot undergo the terms what we call it as anodization. Okay. So first of all, the materials to deal with is different. Second, cathodic protection, we call that impulse current cathodic protection. Okay, so we supply the electrons, okay, to the iron to prevent the losing or the losing of iron when it comes with contact with air. And how about aluminium? What does it mean by anodization? I put it into the anode. Okay, by doing so, they will undergo oxidation, which form or the layer of oxide, aluminum oxide, to thicken the layer of oxide layer onto on the surface of aluminium, in aim to increase the corrosion resistance of aluminium. Okay, so that two terms mean two different things. First of all, that two treatment method deal with two different metals. Second, the principle, they are different. Can you get the point? Can you get the point? So this is what I would like to share with you about this one, metals. I found that it's still worthwhile to spend an hour to go for a few, because if you go into detail, then there are some more to tell. Something more to tell in terms of explanation of the principle behind. Questions today? Now here comes exit base for Chem 1 in the coming lesson. So like Wenjing, you should prepare, and Pong Kao, you should prepare. Just 1 mark for Cedric, right? You just give a thumbs up, which means 1 mark only.
史 Sir， 不如講一次，因為頭先 miss 咗，可唔可以講一次 metal plating、metal coating 嘅分別啊
？Metal plating 咧，其實啦，你好得意嘅，你講 metal coating、metal plating 有咩分別？嗱，其實咧，如果繼續再上網去睇咧，其實你問我係咪一個好特別嘅分野咧？其實冇乜特別嘅定義嘅分別嘅。點咁講咧？因為咧 coating， 即係 coating 咧，其實可以就係講緊有一陣嘢走咗喺面咁冚埋佢，咁叫 coating 啦。咁 plating 咧，嗰個如果講緊個要求高低啊，首先第一樣嘢，即係有啲人有咁樣講嘅個感覺上邊，整嗰陣 coating 咧，就咁一陣有嘢包含住就叫 coating 咯。plating 咧可能係一啲比較 uniform 少少嘅 layer of metal 就冚起面，咁就叫做 metal plating。咁但係個 metal coating 嗰個 coating 可以係乜咧？其實好多嘅。你自己上網睇啦，就係你會見到有好多唔同種嘅 coating 嘅，例如係一叫如果你話 coated metal coated by something 嘅話，咁你就可以有好多嘢 coat 上面啦。咁但係如果你講 metallic coating 咧，咁就一定係一陣 metal coat 起面。如果係就咁寫 metal coating 咧， 就唔清晰嘅，即係究竟佢講緊係一陣金屬冚起面啦，係一陣即係一陣 coat 即係面頭冚咗上去嗰樣嘢係一個 metal 啊，定係啲其他嘢咧？嗱，咁我冇講過啲乜嘅，得唔得？呢度係冇講過啲乜嘅。咁第二咧就係、究竟你話係 coating 又好 plating 都好，如果我哋大家共通都係講緊係一浸金屬冚落去個面嗰度咧，就有兩種方法嘅。咁一種咧就係 electroplating， 第二種咧就係 hot dipping。咁 hot dipping 咧就係朱古力噴泉啊、芝士火鍋咁啦，係嘛？成個熱嘅金屬就浸落去，即係一啲要溶嘅金屬裏邊拎翻出嚟，咁去做浸 coating 咯。咁啊整一浸比較即係有一浸 layer of metal 咯。但係而 electroplating 咧就係喺一個 electrolyte 入邊經過電啦 electricity pass through 啦，去就係將 electrolyte 嘅 cation 咧就 reduce 變咗浸一浸嘅金屬就 coat 咗喺面嘅。咁所以咧兩個方法咧係有唔一樣嘅做法嘅。咁簡單啲講咧就 deal with 唔同嘅金屬啦。例如係話electroplating 嗰啲咧就係、可能本身個活潑性比較低啲嘅。咁我直接咧用 electroplating 都會做到。點解會做 electroplating 定 hot dipping 咧？就係、因為咧 electroplating 咧嗰陣 layer 咧係會容易啲控制個 thickness 多啲嘅。因為 hot dipping 咧其實係同嗰個溫度有關啦，個 object 嘅有關，即係嗰個 hot dipping liquid 有關啦，個 object 嘅大細有關啦，浸嘅時間有關啦。咁其實呢啲係難控制過 electroplating 嘅，其實。咁所以如果你想整嗰隻 product，你想整嗰陣 layer of metal 冚面咧，嗰個 quality control 做得好啲咧，其實我哋啲人咧都會傾向用 electroplating 多嘅。咁但係 hot dipping 咧都有佢嘅優勢，因為快啦、平啦、容易啲做咯。咁但係 electroplating 全部係用時間去堆砌嘅，咁所以咧就有兩個嘅分別啦。得啦，咁你咪睇下個 metal coating 係咩意思咯。如果你想講 metal coating 係一個 method 啦，定係嗰陣 coating 係 metal 咯？你明唔明講緊係咩意思啊？即係其實點解你會覺得好 confuse 咧？因為呢個 metal coating 係好 ambiguous 嘅呢個 term。你可以話係個 coating 係一個 metallic coating， 你都可以話個 process of coating something on the piece of metal， 嗰啲 metal coating 有得㗎，得唔得 ？OK， 咁所以呢度係比較即係太 general 呢個 term， 所以咧就如果俾你揀咧，就千祈唔好咁寫呢啲嘢。反而咧，你會搞死自己，因為你而家都覺得 confusion， 其實 marker 都要有 confusion， 明唔明啊？咁所以咧就唔好揾自己笨啦，咁寫得清楚啲，用咩嘢方法，咁就最好啦，得唔得 ？OK，get 到啦，好係咁咯，拜拜，唞唞先。